network paths. And we also propose an extension to the random peer selection algorithm, which we call AF. I was interested to note that the AFBit and the ANT has a symbiotic relationship in nature. That's where the naming convention comes from. So we have. So now let's talk about ANT. So what happens? Now consider the fact that we have swarm A and swarm B1, swarm B2. Now everyone is sharing the same file. That's important to note. Now what happens is that you'll notice that there are two distinct trackers, tracker A and tracker B. Now be aware of the fact that they are totally unaware of each other. Let's take a look at this. So what happens is swarm A1 is shared with swarm A2 and swarm B1 is shared with swarm B2. They're totally ignorant of the fact that there exists a swarm. They're independent. Swarm A and swarm B1 are independent of each other, but however they exist on the same access ISPs. So as far as the ISP is concerned, these guys could effectively be saving us some money. Yes?
Are you assuming that they're both sharing the same file?
Yeah, they are. In effect, what I'm saying is that the trackers do not communicate, and there is a level of redundancy in terms of, for example, there are a lot of tracker websites, and anyone can set up their own tracker. If your tracker is sharing a particular file, and my tracker is sharing the same file, we could effectively communicate with each other and share that information, so therefore we can intend localized traffic. You understand what I'm saying?
But that's not going on now.
No, it's not going on now. No. That's what we're about to propose, sorry. But, Manfred, you?
Well, I don't see this happening in real life.
Actually, well, we looked at the top 10 trackers, and we found that on average, the top 3 files were duplicated at least 3 times on each tracker. It does happen a lot for a lot of popular content, because what you have to understand is that one big tracker doesn't exist. A lot of trackers exist. And if there's one particular file, it exists on a lot of different trackers, all shared. So there is a duplication.
So I imagine you might have the same file and you make the same, like, you then make a torrent file, right? And then you make a tracker from that.
Well, no.
But those torrent files aren't even going to be the same.
Yes, they are. The torrent file, actually, the way it works is that the torrent file looks at the content of the file. And the torrent file stores hashes of every piece of that file. So in effect, there's a unique identifier in the torrent file that identifies the file. So in effect, yes. And that's what the our network aware tracker will be looking at. It's just a hash of the contents of that file which uniquely identifies the file. You're right, the torrent files may be named something differently, but in effect, the content is the same. And that's what you use to identify it. So let's, okay, so we have 2 independent swarms going on, and we see that it's costing the ISP some money. What we wish to propose is ANT. And in fact, what ANT would do is inspect traffic from the tracker to its peers. So in effect, notice that, hey, I have 2 local swarms going on here, which could potentially share traffic. Then ANT would inform tracker A, hey, you have some friends over on swarm B1, and do the same to tracker B. In turn, those trackers would disseminate that information to their respective peers. And effectively, what we will have at that point is a localized swarm where they would, we hope, share among themselves, reducing the ISP money, hopefully not even reducing time performance, and reducing the traffic on the costly links. So that's what, so ANT, we're hoping that ANT would detect that duplication among swarms. Now, I would localize P2P traffic by merging swarms. So, okay, let's first evaluate this idea and see what would really happen if that were really possible. So to do that, we utilized the Open Network Lab and we decided to, let's put this idea to the test and run BitTorrent on a series of hosts and see what type of link utilization we would get. So I described to you our setup. This is ONL, I mean, it's the Open Network Lab, I think most of us are familiar with it. What we are gonna do is set up a similar configuration like the one that we're just looking at. And in effect, we have 15 peers, that's 15 end host computers, each participating in the download. And we have 2 peers with the complete file. Notice the costly link. And we're going to consider 2 cases. We're going to consider one case where this is one tracker and one localized swarm. And another case where we have 2 independent swarms and 2 different trackers. Now, the reason why we have 2 different trackers in this case is because we're just trying to simulate what ANT would effectively do. This is not assuming that there's one tracker, two tracker. We're just saying that ANT will effectively merge two trackers into one. So this is just like a simulation for us to kind of evaluate the benefit of actually pulling this off. So now we go ahead and we ran the simulation a few times. We got some data, and what we noticed is that with the one swarm case and the two swarm case, the link utilization is shown on the left. Link utilization for us is in terms of how many pieces of that file, how many times does that file get transmitted across the wire? Because link utilization is the total traffic divided by the file size. So in fact, we say in one swarm, 2 files were transmitted. And with 2 swarms, 8 copies of that file was transmitted across the costly link. So what we can see is that there's like a 400% increase in link utilization with 2 independent swarms. And in effect, the advantage, because if you notice that in previous case, we had 2 swarms, and you notice that the increase in download time for having those 2 independent swarms is very minimal. It's only 40% decrease in average download time. Anybody? So what we're saying here is that there's a real potential for actually taking it a step further and localizing ISP traffic. Okay, so
I'm sorry, just I have a question. So the other graph there was download time. So you're saying when we have the one swarm, which is what ANT would conceivably go to, then that increases the download time, and so it's not beneficial to the users to use it?
Yeah, but okay, what are we saying, right? Yeah, you're right, it does increase the download time, but you have to understand that there are more peers. There are 15 peers as opposed to two distinct groups of 7 and 8. So in effect, I'm saying that what I'm really trying to say is that for the utilization of the network, the decrease in download time is a factor of 10. So we're saying that there's room for improvement. You're saying that it...
I think it is right. What we would love, right, would be a 400% increase in utilization and 0 decrease in download time. It's right now it's 40%. Hopefully there's something we can do to make that better. But clearly the savings and link utilization are much, much bigger than the decrease in end user performance.
Exactly, that's what I'm trying to say. So assume that we don't even change. What I'm saying is that there's a big area of, there's a wastage here. There's a significant wastage in terms of network utilization. You see what I'm saying? There's a factor of 10 difference. So that's what we're identifying. So let's move on. So we know that there's some work to be done and there's some benefit to pursuing this. So there's another function of ANT, and ANT also needs to identify to the peers, the swarms, where are these costly peers. So this is how, so we have a local, it's already been localized, so it's already been localized, and these 2 peers are now sharing. Now what we'll learn about BitTorrent is that the random peer selection is not really that random, it's really a greedy algorithm, and all it does is basically tries to download as fast as possible. So what I'm saying is there's tracker A and tracker B, and ANT has done its function and merged those swarms. However, these guys decide that, hey, we are aware of this cross-ISP swarm, and he's giving us a faster download rate. Why not connect to him, despite the fact that I know about a local swarm? So you have to understand, at that point, what ANT does is it informs these 2 trackers that, hey, swarm C has costly peers. And it's up to the trackers now to inform the peers in the swarms that, hey, you guys need to adjust your peer selection algorithm to account for the fact that there's some costly peers up there. So what we're proposing, you see, now this is where AF comes in. AF is an adjustment to the peer selection algorithm. Because what we're saying is that despite the fact that these swarms have been localized, the peer selection algorithm does not take that into consideration. It will always pick peers which it's receiving the fastest from. So in effect, even localizing that swarm might not produce the type of potential benefit that we just saw. So that's where we propose a method of modifying the random peer selection algorithm. So how do we propose to do this? Now, typically the peer selection algorithm operates in rounds, and in each round, it recalculates the receiving rates it received from the last set of peers. So first of all, let's identify that ANT has actually marked 2 peers as being expensive, meaning that they are on expensive paths. And the peer selection algorithm then would recalculate the download rate at the start of round 1, and then it would order the peers by rate. So you notice that the rate of peer 4 increased, so it's now you know, as far as BitTorrent today is concerned, the most favorable pair. So it does its reordering, and then